Okay, so in this next section, we're talking about simplifying a complex fraction. And you may be asking yourself, well, what's a complex fraction? Well, first let's go over the objectives. We are going to simplify by doing actually a division problem first. And if we have negative exponents, we're going to simplify those before anything else. So here's your definition of a complex fraction. It is a rational expression. Remember, rational means what? That's right, rational means fraction, whose numerator, denominator, or maybe both of them, contain one or more rational, which again means fraction, expression. There are two methods that can be used, but we are only going to chat about one method. I do not want to get two methods confused. The homework, the authors of the book have put both methods in the homework. If you like the second method, then by all means use it. But we are just going to talk about one method here today. Okay? So we are going to simplify a complex fraction. So first off, we need to make sure that the numerator and the denominator have a single fraction in them. That's first and foremost. And once they do, we can actually divide. And you know how to divide fractions. We actually have to multiply by the reciprocal. So, and then of course reduce if possible. So let's check it out. Here's our first example. All right? We are going to look at this particular fraction, and we are going to ask ourselves first and foremost, this line separating the numerator and denominator, we need to know what that means. If we understand what that means, then we understand what they want us to do. This line means division. So I've got one fraction on the top divided by one fraction on the bottom, which in the previous slide is exactly what we needed. We needed a single fraction in the numerator and a single fraction in the denominator. So, but you know, we're not used to seeing a division of fraction problems like this, are we? So my recommendation is we rewrite it. We rewrite it as we're used to seeing it. So this could be rewritten as the top fraction divided by the bottom fraction. Now, remind me, do we ever really divide fractions? Correct. The answer is no. What do we end up doing? What operation? That's right. We multiply. And do both fractions stay exactly as they are? Good. You remember, fraction 1 stays the way it is. Fraction 2 flips over. We reciprocate it, is the technical terminology. And then we get to multiply numerator with numerator and denominator with denominator. But before we do that, remember, what we would ideally love to do is cancel. Because if we can cancel, it's going to make our lives a lot easier, isn't it? Now, do you notice that there is multiplication in between the 3 and the a, the 5 and the b, the 9 and the a squared, and the 25 and the b squared? Do you notice there's multiplication between all of them? That's a good thing, because remember, as we've spoken about before, if there's not multiplication, then there's no canceling that can be done. So gratefully, I have multiplication. So for some of you, this might be a better way to rewrite the problem. You've got 3 times a times 5 times b all over your 25 times b to the second times 9 times a to the second. Some of you are like, do I have to do that? Of course not. Others of you are like, I kind of like that. Then go for it. So here's what I'm noticing. I'm noticing the 5 and the 25 will reduce. 5 into itself once, into 25 5 times, right? And then I'm noticing the 3 into itself once and the 3 into 9 3 times. Yes? Okay. Well, that's a funky looking 3 now, isn't it? So let me fix that before we go further. Okay, now let's look at the variables. I'm noticing that I can do some canceling with the variables. I see an a to the first power here and an a to the second power there. So one of these a's on top goes away, and I'm left with a single a on the bottom, aren't I? I have b to the first up top and b squared on the bottom, which means the b on top goes away, and I have one b left on the bottom. So if I take a look at what remains, in the numerator, I'm just seeing a couple of ones, and so 1 times 1 would just be good. And in the bottom, I'm seeing a 5 times a 3, which gives us 15. I'm seeing a b times an a, which gives us a b. So, looks like our answer is 1 over 15 ab. How's that? Good? Cool. Let's look at the next example. So again, we have this line separating two fractions, don't we? I have one fraction on the top, and what does that line mean again? Right, division, divided by a second fraction. But you know, you and I probably prefer this rewritten in another way. So we have the top fraction, and it is being divided by the bottom fraction. Okay, but remember, how do you divide fractions? That's right, it becomes a multiplication problem. Do both fractions stay the same? Agreed, they do not. So fraction number 1 stays the same. Fraction number 2 flips over. And I have a multiplication problem. And we know how to multiply fractions. We are going to first see if we can reduce. And I'm noticing, thankfully, there's multiplication between the 6 and the x, which means I can cancel the 6 into itself and into 12, right? Now, do you notice on that x plus 5 and x minus 5, this is superglued with addition, isn't it? This one is superglued with subtraction, isn't it? So can I cancel the x's? Agreed, you cannot because they're superglued to the 5's. Can I cancel the 5's? Agreed, you can't because they're superglued to the x's. So can I cancel the x plus 5 and the x minus 5 with each other? Agreed, you cannot because they are not exactly the same. It's not kinda only works in horseshoes. It has to be exactly the same. And since they are not exactly the same, no canceling. Got it? Okay, which means if I look in the numerator, I have x plus 5. And if I look in the denominator, I've got a 2 and my parentheses x minus 5. Not much more to cancel, is there? And I would leave that alone. Good? Okay, let's look at this example. So, gratefully, I'm seeing this line, which means divided by again, right? But there's something different about this problem than was in the last problem or even the problem before it. In examples 1 and 2, I only see one fraction on top and one fraction on the bottom. But in this example, oh, it's not just a single fraction, is it? Guess what we're going to have to do first? Yeah, we're going to have to do some addition and subtraction to get a single fraction. I want this written as a single fraction because if this is not written as a single fraction, then I don't know what I'm dividing. I don't know what the top is to divide by the bottom. I need both of these to be single fractions. So, here we go. We basically have two problems to work on, don't we? So let's go over here and do some side work. I have x over 2 plus 2, don't I? But it's 2 over 1, yes? I need a common denominator, agreed? And that common denominator would be, that's right, the common denominator will be 2. So, fraction number 1, that's good. Fraction number 2, I need to multiply the bottom by 2, which means you also have to multiply the top by 2, don't you? So when you do that, you end up with x over 2 plus 4 over 2, yes? Which means you end up with x plus 4 over 2. Is that agree? Okay, so there's the numerator. X plus 4 over 2. Now, I need to work on the denominator. So my denominator is x over 2 minus 2. I should probably write that as 2 over 1. And once again, I need to see about a common denominator. And in this case, it is 2 again, which is fine. Sometimes they're the same and sometimes they're not. So fraction number 2, we need to multiply top and bottom by 2. Agreed? Which means, let's see, the first fraction remains x over 2. The second fraction is 4 over 2, which means I get x minus 4 over 2. So, I have x plus 4 over 2 divided by x minus 4 over 2. Okay, single fraction on top, single fraction on bottom. Now I can literally work on my division problem. So my division problem is x plus 4 over 2 divided by x minus 4 over 2. And again, we know that division of fractions will always turn to multiplication, and fraction number 2 is the one that flips over. Yes? And do you notice that I can cancel these 2's? They both turn into 1's, don't they? So, here's the $64 question. Can I cancel x minus 4 and x plus 4? Can I cancel just the x's? Can I cancel just the 4's? What do you say? Good. I heard a no. You're right. You can't. Because they're super glued to each other. X and 4 are super glued with a plus sign. X and 4 on the bottom are super glued with a minus sign. That makes them different. Which means in the numerator, I just have x plus 4. And in the denominator, I have x minus 4. And that will be our final answer because there's nothing else I can cancel because of the super glue. Cool? Y'all with me? Loving it. Okay, got another one for you. They did it to us again. I have 2 fractions on the top, 2 fractions on the bottom, which means we're going to have to do what? Yeah, first we need a single fraction in the numerator and the denominator. So, let's talk about the numerator first. I've got 1 over y squared plus 2 over 3. I need a common denominator. Any ideas? Remember, we have to make them look like each other, right? So I'm noticing this y squared doesn't have a 3, which means the top needs a 3 also. And I'm noticing this 3 doesn't have a y squared, which means the 2 also needs a y squared, doesn't it? So it looks like we have 3 over 3y squared plus 2y squared over 3y squared. And since the denominators are the same, we have 3 plus 2y squared all over 3y squared. What do you think? Loving it. Okay, so here we go. I am going to make my line separating the numerator and the denominator first. And now that we have the numerator as a single fraction, I'm going to write descending order. You guys okay? You with me on that? Good. Loving it. All right, let me put that 3 back. All right, now it's time to work on the denominator. And the denominator is 1 over y minus 5 over 6. And again, same deal. The denominators are different. We can't have that. The denominators must be the same. So I'm noticing this y doesn't have a 6, which means the top needs the 6. And I'm noticing the 6 doesn't have a y, which means the 5 needs the y also. So it looks like we have 6 over y minus, 6 over 6y minus 5y over 6y. Since the denominators are the same, looks like we can go ahead and subtract them. So I am going to write again in descending order a negative 5y plus 6 over 6y. Okay, a single fraction on top, a single fraction on the bottom, which means we can change this to that division problem that we're used to seeing. And again, question, do we ever really divide fractions? Right, the answer is no. Which fraction flips over? Because we know it's going to turn to multiplication. Good, fraction number 2 does the flipping. So, okay, help me out. In order to cancel, we need what operation? Good, multiplication. I'm noticing there's multiplication between that 6 and y, and between that 3 and y squared. So I'm going to cancel 3 into itself once, and into 6 twice. This is a y to the first power, and there's a y squared down there, which means bye-bye goes this y. On the bottom, I'm left with a single y. Okay, let's look at these other two guys. The 2y squared plus 3. Can I cancel the 3 with that 6? Correct, you cannot, because I don't have multiplication. These are addition problems, which means those things are super glued together, and you can't break them apart. No way, no how, not even. So, we are going to see what is left. I'm noticing in the top, I've got a 2y squared plus 3 with a 2 as well. And on the bottom, I've got a y and a negative 5y plus 6. And so some will leave the answer this way, some authors, and some authors will distribute. Either way is fine. If you distribute, you will end up with 4y squared plus 6. And on the bottom, you have a negative 5y squared plus 6y. Okay, question, can I cancel those y squareds? Good, good. No, 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 no. This and this are what? Super glue. No canceling, which means that is your final answer. Got it? Love it. Okay, got another one for you. No surprise, you should have been expecting it. So here's the deal with this one. I am noticing the top is a single fraction. This is a yay! I'm noticing the bottom is not a single fraction. Boy, I need a single fraction in the denominator. This is making me do work, but that's okay. We know how to handle it. So I have x over y plus 2 over 1, right? And remember, you need these things, these denominators, to look exactly the same, don't you? Well, it looks like fraction number 2 is just missing a y on the bottom, which means I need a y on the top. Agreed? Which means we have x over y plus 2y over y. And since the denominators are the same, we have x plus 2y over y. Whoops! Good goodness for erasers. Over y. Do you agree? All right, so let's check this out. We said the numerator was okay because it was a single fraction. Let's try that again. So the numerator is okay because it was a single fraction. And now I've got the denominator as a single fraction. And remember, what does this line mean separating the two? Yes, it's a division problem. It's a division problem, which means we are going to be dividing. And we have that first fraction, the top fraction, divided by the bottom fraction. But you know as well as I do, division turns to multiplication, and fraction number 2 always does the flipping. Anything we can cancel? Yeah, that was wise. Into itself one time. Agreed? Which means I have x plus 1 over x plus 2y. Okay, here's my question to you. Can the x's be canceled? Excellent, they cannot, because that plus sign and that plus sign act like what? That's right, super glue, which means no canceling allowed. It either is all going to cancel or it's not, none of it's going to cancel. And in this case, none of it's going to cancel, which means your final answer will be x plus 1 over x plus 2y. Good? Awesome. Let's make that a 2 so you can see it a little better. There we go. Okay. Occasionally, we end up with negative exponents in these fractions. And you have to remember what a negative exponent does. It never makes the answer negative. Never, 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 never. Negative exponents. Never, never. Big bold letters. Highlight it. Always remember it. Never. They never make the answer negative. Never exponents. Never make the answer negative. That is not their job. You have to remember what the negative exponent does. If I have x to the negative 1, that means that x is in the wrong space or place. It doesn't belong on the top, it belongs on the bottom to the power of 1. And there is this imaginary little 1 in front going, hey, I'm still here, which is why there's a 1 on top. And on the flip side of that coin, if you had 1 over x to the negative 1, that x having a negative 1 on the bottom means it's in the wrong place, so it goes to the top. And this 1 stays on top because it doesn't have a negative exponent. And, you know, that guy had an imaginary 1 on the bottom, which is why there'd be a 1 on the bottom. So this one would just simplify to x. Cool? All right, let's see what they got for us. Such a lovely problem. Okay, here's what I need you to think about. I need you to keep that division line right there. All right? I need you to keep that there. And I need you to treat this as 2 individual problems. So first, here's how I want you to look at it. My numerator is x to the negative 2 and y to the negative 2. Yes? That would mean I'd have 1 over x to the second times 1 over y to the second, because there's multiplication there. Agreed? Which means I'd have 1 over x squared, y squared. Do you agree with that? Good. So there's my numerator. 1 over x squared, y squared. Okay. Now, let's look at that denominator. My denominator is 5x to the negative 1 plus 2y to the negative 1. Now, question for you. Does this 5 have a negative exponent? It does not. So since it does not, will it move? Agreed. It will not move. It stays on top. This x, however, has a negative exponent, which means it doesn't belong next to the 5. It belongs underneath the 5. So, how about that 2? Does it have a negative exponent? Agreed, it does not, which means this 2 will stay put, but the y having the negative exponent tells me it doesn't belong next to the 2. It belongs under the 2. And there it is. Yes? Okay, so now, while we're at it, are we allowed to have 2 fractions on the bottom? Good. The answer is no, which means we are going to have to make these denominators look the same. It looks like the x is missing a y, so the 5 needs a y. It looks like the y is missing the x, which means the 2 also needs the x. Do you agree? Cool. Which means I have 5y over xy plus 2x over xy, which means we have 5y plus 2x over xy. So we just found our denominator, and I'm going to put it in order. So we have 2x plus 5y over xy. Agreed? Loving it. Looks like you're getting the hang of it. Okay. So, you know as well as I do that this is not, this is a division problem, that we usually like to have our division problem written as the old-fashioned division problem, shall I say, with our wonderful little division sign. But division doesn't stay division very long with fractions. Division, remember, always flips over to multiplication. And fraction number 2 is one that's actually doing the flipping, right? Okay. And, I see super glue there. But I'm noticing there's multiplication here and multiplication there. And since there's 1x here and 2x's down there, looks like this will cancel to just a single x. I'm noticing 1y on top and 2 y's on the bottom, which means it's canceling to a single y on the bottom. So, all I see is a 1 on top. And on the bottom, I see this xy. And next to it in parentheses, because we are multiplying, is 2x plus 5y. What do you think? Good? In my opinion, I'm going to tell you right now, it is so beneficial for you to do this side work over here. This is like 4 problems in one. You've got to figure out the numerator first, figure out the denominator second, put them back together, and then you could actually do your work. Good? Okay, you guys have fun. I'll see you on the flip side.